All right, question number 1. Construct and graph probability distribution. So first let's construct. So here we have, this is computers. Amount of computers are working, those are households. How many households have 0 computer have 305 households? 1 computer has 282 households. 2 computers have 92 households. 3 computers has 19 households. Well, you can solve this problem in Excel, and I will record how to solve it in Excel, but nevertheless solve by hand with a calculator or piece of paper and pencil. We have to do the following things. First of all, let me remind you that the probability distribution, to find it, first we need to add all the households, how many total households we will have. So let me convert this into X. Computers are going to be X. I'm rewriting in mathematically X. And the percentage wise, what does that mean? Let's say 305, 282 houses, 92 houses, 19 houses. What does that mean percentage wise? So probability of X. So we have 0, 1, 2, 3, 4, 5. Maybe I should move a little bit further, leave some space, because I didn't leave enough space. So 1, 2, 3, 4, okay, and 5. Okay. Now, how to find out the probability? To find the probability, first I need to find out the sum of all households, right? How many will be? I need to add all of them. And sum of all households. Households. It's going to be 305. That's why Excel is easy to work with. Okay, let me punch it. It's going to be 305 plus 282 plus, you know what, let me do it by hand. 305. I don't like calculator anyway, and you can benefit from it, and plus 19. So we add it. So 5 plus 2 is 7, 9, and 9, 18. So 8 and 1 in mind. 0 and 8, 8, and 9, 17, 18, and 1 will be 19. Again, 1 in 9 in mind. 3 plus 5 is 3 plus 2 is 5, and 1, 698. Okay, so for the probability for 0 computers, it's gonna be 305 over 698. For probability for computer households having 1 computer, it's gonna be 282 over 698, and then 92 over 698. Let me see, I thought I have 5 of them. It's changed. Okay, So then we have only 3. It's going to be easier. Then it's better. Yeah, because previously I opened, there was 5 of them. That's fine. And we have 19 over 698. Okay. So how much that gonna make? Here is x. Here we have probability of x. And I will have 0, 1, 2, 3 computers in household. So 305 divided by 698 is gonna be, what is it? 305 divided by 698. It's gonna be 0.437. For the probability for one computer, it's going to be 0.404. For probability of having 2 computers, it's going to be 92 over 698, which is going to be 0.132. And probability for having 3 computers is going to be 0.027. Okay, so once I have this probability, next step I am going to do, I am take this x and multiply. Let me write down the formula. Actually, yeah, this is, I'm heading further. So this is going to be your case A, which is the construct probability distribution. That's it. And this is your probability distribution. Okay. Highlight, I changed the color so you can see. This is your probability distribution. All right. So if we build this probability distribution in the format of histogram, this is what we're going to have. Ah, yeah, I didn't want this color. Okay. Okay. So we are going to build, so we have 0.434, 0.404, 0.132, 0.027. Okay, approximately I'm going to build like that. This is 0.1, 0.2, 0.3, 0.4, 0.5. Okay, now here it's going to be, this is going to be 1, this is going to be 2, 3. Okay, we have it. So first thing, for 0 computers, we have 437. So if this is 4, 0.4, right? 37, it's going to come, let me see. Let me make it easier. 1 second. One second. I'm going to make 0 as a data, not as a the beginning point in the graphing environment. 0, 1, 2, and 3. All right. So this is what's going to happen. It's going to be, in 0, it's going to act as a midpoint, actually. So I would like to bring this one also to be precisely, all right, like this. So 0.4, it's gonna be right here. 0.437, it's gonna come here and this way down. Second one computer, I see I keep as a midpoint, right? 0.404, it's gonna be slightly down. Okay. Next, 0.132, which is gonna be 132 from here. And lastly, amount at free as a midpoint, 0.027, which is gonna come somewhere here, right? There we go. So take this, I will shade, I will shade this. It comes out very ugly. Okay, next I'm going to shade this. Okay, and then this. And use this one like this, and this is going to be our histogram for probability distribution. Okay, so what we will have, this is going to be our 437, this is 0.404, 0.132, 0.027. Okay, moving to next question. B, we need to find describe the shape. Well, obviously it's absolutely clear. It's skewed to the right, right? Skewed to the right. Okay, question number 2. So we are given probability distribution well, I guess I'll go without. Not bad. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, not bad by hand. So what do we have? Here we have x. 3, 4, 5, 6. Oh, this x I supposed to write inside. That's okay. And here I have probability of x. It's given 0.25. This one is not given. We need to find out. 0.26 and 0.22. So what does it say? Determine the required value of the missing probability to make distribution a discrete probability distribution. Required value. We know one thing. So when I add all of this up, then when I add them up, I have to get is equal 1, right? Sum of all probability of x is supposed to be 1 or 100% because it's percentage. So if I need to know this one, question mark, right? All I have to do, 1 minus 0.25 minus 0.26 minus 0.22. And the answer will get 0.27. So the missing one, it's going to be 0.27. Okay? Question number 3. So complete parts A and B below. All right. So we have the number of dogs per household in a small town. Okay. We need to find out. So how many dogs? 0, 1, 2, 0, 1, 2, 3, 4, 5. So 0.651, 0.221, 0.084, 0.025, okay, this is 4, and 4 dogs, it's probability that 0.013. So actually you see the more amount of dogs we get, the less is a chance that people will have that many dogs. Okay, so here we have amount of dogs. Here we have probability. All right, so A. We need to find the mean, variance, and standard deviation for the probability distribution. Okay, for the probability distribution formula, mu, mean, average. For the discrete probability distribution, mu is equal sum of x times probability of x. Yes? So, do we have x? Yes, that's a dog. Amount of dogs, right? This is our dogs, x. And here is probability of x. Okay, now I'm going to provide third line here, and underneath I'm going to put probability distribution. So here I will have x times probability of x. So which means it's going to be 0 times 0.651. Well, I will need much more space. Okay, I'll go through formula. Not a big deal. So here we have 0 times 0.651 plus 1 times 0.221 plus twice times 0.084, okay, plus 3 times 0.025 plus 4 times 0.013, and lastly plus 5 times 0.007. So what I did, I'll just multiply x by its probability, okay? And so on. And that's all I did. And the result is going to be 0.6. Now, 0.6, it's rounded up. So you're actually going to get somewhere 0.59 something or whatever. Okay, and you round up, you get 0.6. Next, for the variance, sigma squared. For the variance, sigma squared. I'm going to use calculator that is going to be placed under the video. Variance for the discrete probability distribution. All you have to do there, place the value of probability of x and x, these two values. There are three the frames where first one is name of the random variable. You don't need it, it's optional. All you have to do, place the value of x. In second frame window, you are going to place probability of x, which you have everything here. So the variance in this case, if I place it, let me see, 0, 1, 2, 3, 4, 5, and let me, if you plug it there, you are going to get variance 0.9. Variance is going to be 0.9. And accordingly, if you take square root from the variance, yes, it is going to be again 0.9. Well, to be precise, let me see. To be precise, sigma squared is going to be 0.8894. So, which approximately 0.9. And sigma, if you take square root of 0.8894, it's going to be 0.9431, which is approximately, it's going to be still 0.9. All right? Now, for the people who want to build in Excel and use the formula, you are going to use the following formula. Sigma squared for variance is going to be equal sum of x minus mu squared times probability of x. So all you have to do, find the average, and you have the average 0.6. So you can go one by one. For every x, let's say 1 minus 0.6, 2 minus 0.6, 3 minus 0.6, right? And then square every single result, and then do times probability of x. I will record it on Excel, whoever want to learn it. And then the sigma will be accordingly, it's going to be square root of sigma squared. That's it. All right. moving to next question. Wait, we have another question. So we need to, as a B, we need to do interpretation of the result. That's a good point. Very good point. So what can we say here? The household on average has how many? 0.9 or 0.6 or 0.5. Dog with standard deviation of 0.9. How much is our standard deviation? 0.9, yes? So standard deviation 0.9 and our average is 0.6, which means we can say from here that household on average has 0.6 dog. It doesn't mean half of the dog, obviously. Forgive me for saying so rough, 0.6, but that means one household doesn't have any dog, the other one has 2 dogs, so in average comes out 1, right? Like that. We are talking about average of dogs. So, all right, which means household with average 0.6 dogs, 0.6 dogs, with standard deviation 0.9. Okay? Question number 4. Wait, this was question number... Okay, 2, 3, yeah. Yeah, I'm looking where is... Okay. So question number 4. Let's see, what do we have here? Okay, students in a class take a quiz with 8 questions. Okay, so what do we have? 8 questions. This is X, and this is probability of X. And 8 questions. To be safe, I'm providing long line. So 0 with 8 questions, 0.02. And then for 1 question, it's going to be 0.04. Let me write this down. 2 questions, 0.06. 3 questions, 0.06. 4 questions, 0.09. 5 questions, 0.22. 6 questions, 0.31. 7 questions, 0.15. 8 questions, 0.05. And 9 questions, no, 8 questions, okay. 8 questions, okay. Students in a class take a quiz with 8 questions. The number of X questions answered correctly can be approximated by following probability distribution. Those are probability of answering correct, chance to answer correct these questions. First, from no correct question at all, which is 0, and then the correct 1 question, 8 questions, and so on. So, first thing, we need to use probability distribution to find mean, the standard deviation, and we need to find variance. Okay? And then we need to find expected value. All right. So first of all, we need to find mean. Use the probability distribution to find the mean of the probability distribution. the mean is going to be equal, and this is A, mean is going to be equal sum of x times probability of x, which is going to be equal again 0 times 0.02, and then plus 1 times 0.04, plus 2 times 0.06, and then I put plus, continuing, plus 7 times 0.15, and then plus the last one 8 times 0.05, which is going to be equal, total is going to be equal 5.1 if you round it up. Okay? B. So to find variance, okay, formula we already have here, I wrote down right there. If you want, I can rewrite it again. X minus mu squared times probability of x, that's right. And all you have to do, you have mu right here. You have x's, those are all x's all the way to the end, x's, and you have probability of x, right? Okay, so you can plug x and probability of x into calculator, which will be given. I don't trust it. This calculator calculate mean also, but it has slightly difference. I suspect they don't use entire set of 3 digits. They just round it up too early, and sometimes it doesn't match up. So I would recommend to calculate mu on your own, the average. But with the standard deviation and variance, yeah, you can do it. I tested, calculator gives me the answer. If by some reason it's approximately 3.4, if you get a slight difference in decimal notation, obviously contact me. Okay, C. So use the probability distribution to find standard deviation. To find standard deviation, what we're gonna do? Of course, square root. So that means square root 3.4, and that's approximately going to be 1.8. You are going to round it up. Okay? And D, we need to find the probability distribution, use the probability distribution to find expected value. What is expected value? Expected value, nothing else but your mu, which our mu is 5.1. So we'll just write down this point of 5.1. Yes? Now, what interpretation we can make? That expected number of questions answered correctly, in average, expected number is 5.1 with standard deviation 1.8. So E, the expected number of correct questions, correctly answered questions, is 5.1 in average. Let me make this 5 nice looking so people can read. 5.1 in average. Okay, with standard deviation equal 1.8 questions. Okay? Question number 5. So, let's see what we have. Well, we are going to deal again with amount of dogs. Let's say I write down dogs as an X. And probability, it's going to be probability of X. So we have 0. Dogs has a chance 64.7% or 0.647. One dog 0.222. Two dogs it's 0.084. 3 dogs 0.025. 4 dogs 0.015. 5 dogs 0.007. It's not the same probability, is it? No. All right. So A. Find the mean. All right. It's going to be same thing. So mean is going to be equal 0 times 0.647 plus 1 times 0.222 plus 2 times 0.084 plus blah 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 and plus 5 times 0.007, and the result you get 0.6. B. So next we need to find the variance, sigma squared, which formula we know, right? Sigma x minus mu squared times probability of x. So if you plug, you have again, here you have your x, unit x, which is this one. Unit your mu, which is this one. And let's see, I can do better. So this is your x, okay. This is your mu. And here you have probability distribution, like this one, which is going to be this. Okay. So if you use it or plug in the calculator, result is going to be 0.9. Accordingly, the standard deviation, square root of 0.9, it's going to be equal again 0.9. Don't get confused. It's not 0.09, so you can get 0 free. It's 0.9. If you plug it in the calculator, you will see. Okay? And lastly, what do we have? Actually, this is all under A. That's fine. And if the B question, do interpretation. So it's, we already know, right? The average. The average has, for average, okay. I try to avoid to write the whole thing, but household on average has 0.6 dogs. Again, it's not 0.6, it's just average, right? One has 2, one has 5, one has 1. So if you add them up and divide, it's going to be 0.6 dogs. 0.6 dog with standard deviation 0.9. Question number 6. We will do one more similar problem. So here we're going to deal with overtime hours. So overtime hours. I'll put this an X. And here we have probability. Okay. So we have 6 overtime hours. So from 0 to 6, this is 0, 0.02. 1 hour overtime, 0.093. 2 overtime hours, that is 0.127. 3 overtime hours, 0.284. 4, 0.23. 5, 0.162. And 6, 0.084. Okay. So A, find mean, variance, and standard deviation. So mu is going to be equal 0 times 0.02 plus 1 times 0.093 and plus blah 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 plus at the end 5 times 0.162 plus 6 times 0.084, and result you should get 3.4. Okay, variance, which is sigma squared. Variance, if you plug in the formula or plug in the calculator, so you are going to get at this point 2.1. Okay, sum of x minus mu squared times probability of x. If you plug in, you're gonna get 2.1. So in the calculator, you're gonna place only x overtime hours and probability accordingly, and it will give you variance. And the standard deviation, obviously, it's gonna be square root of 2.1, which is gonna be 1.4. All right, and as a B, we can say that an employee okay, works an average of 3.4 overtime hours, 4 overtime hours, with standard deviation 1.4. Okay. Question number 7. Okay, question number 7. Mean, variance, standard deviation. Okay, okay, we are going to use the same thing, but using this time histogram. We are going to use this time histogram based on histogram. So this is what we're going to have. Question number 7. I'm going to build histogram. So I'm starting, 1 is coming from here. One, two, three. And then another one goes much higher. And then it's coming down. And a little bit more. And here it's going to be identical. 2, 3, 1, 2, 3. Okay, so let me shade it. I'll shade light one. Okay. Because that's a histogram. Okay. Okay, real quick, so there won't be I don't want to spend much time on this. Okay, good enough. So what do we have? Probability of this one 0.257. Probability of this one 0.324. Then probability is 0.153. And then 0.133. And then 0.067. Okay, and this one is, let me see, 66. 0. This one is supposed to be 66, so slightly down, like this. Oops. Okay, here is 1, 2, 3, 4, 5, 6. Okay, let's see what we have here. So, use the probability distribution on histogram to find mean, variance, standard deviation, and expected value on the probability distribution, and make interpretation the results. So the histogram shows the distribution of household sizes in country A for the recent year. All right, let's see how we are going to solve. This is probability of 1 is 0.257, yes. Probability of 2, this is this 2, is 0.324. Probability of, let me see, probability of 3 is 0.153. Probability of 4 is 0.133, and so on. Okay, so let me write down. Probability of 2 is 0.324. So, and blah, blah, blah. We are getting probability of 6 is equal 0.066. So if we have probability and we have x's was 1, 2, 3, 4, 5, 6, then the mu average of this distribution is going to be sum of x times probability of x, right? Okay, that's mean 1 times 0.257 plus 2 times 0.324 plus 3 times 0.153 and plus blah 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 plus 0.066. And this is going to be 2.627. 2.627. Next, variance. So to find variance, we already know what we're gonna do, right? You can plug in the calculator that I will place in the comments and pin it so you can use it. So sigma squared, once you use your x and mu and probability of x, which is a sum of x minus mu squared times probability of x, that is going to be equal 2.21. It's the reason I don't write it down because it's going to be entire table because for 6. So first one, x minus mu, okay, this x minus this mu, and then second one minus this mu again, third one minus mu, and then square it and then add them up. You can find step by step in the lecture, guys. You can find step by step in the lecture. I believe it's 4.1 or 4.2 lecture. That's where it is. You can find it there. And standard deviation accordingly gonna be square root sigma squared, which is gonna be 1.49. Now we need to find expected value. So here is this is B, this is C. Now I need to find D. Expected value. Expected value is nothing else but mu. I already told you, which is going to be exactly same value that we have for the average, right? 2.621. Okay. So, and lastly, we need to make interpretation, which means the average household is expected to have either 2 or 3 people. Why? Why 2 or 3? Because result is 2.627, 2.5. So in average, household has 2 or 3 people. And the other thing is, most of the household sizes differ from expected value by 1 or 2 people. How do we know? Standard deviation 1.5. So 1 or 2. We put household sizes. Because it's going to differ based on standard deviation. Since we have 1.5, so obviously we can't take 1.5, and it's so it's going to be household size differs from the expected value by 1 or 2 people. Okay, average we have 2.6, right? Which is between 2 and 3. So therefore, the expected value going to differ by 1 or 2 people because standard deviation is 1.5. Question number 8. Okay, question number 8. It's exactly same problem. I can say see the question Which problems we have identical? 6, 5, 4, that's enough. 4 through 6, either one. 4 or 5 or 6. Exactly same way you are going to solve it. So I'm not going to do that again. Question number 9. Now this is becoming interesting. Here we are going to calculate expected value. Here we have entire problem for expected value. Okay, I turned recording off so I can type it in, so not to make you wait. So let's solve the question here. In the game of roulette, a player can place $6 bet on the number 15 and have 1/38 probability of winning. So let's write down probability of winning is 1/38, which is approximately 0.02613. So accordingly, probability of lose, it's going to be 1 minus 0.026313, right? And that will be equal 0.973684. Okay, so it's placing $6 bet and have 1/33 probability of winning. If the metal ball lands on 15, then player gets to keep $6 paid to play the game, and the player it's awarded an additional $210. Okay, so X amount of win $210. Otherwise, the player is awarded nothing in the casino, and the casino should be, and the casino takes the player's $6. So X of lose is negative $6. Okay. What is expected value for the game player? That's the first question. Let's answer. First of all, so expected value, right? Expected value, it's the same thing as a mu, which is equal sum of x times probability of x. So here we have probability of win. So in this case, it's going to be sum of probability win times win and probability loss times loss. One thing is here is interesting, and I would like to attract your attention. That is, it says, if the metal ball lands on $15, the player gets to keep $6. So which means we don't need to subtract from 210. We are not going to do $6 because it's going to keep it, right? So it's going to keep $6 and getting $210. All right, so let's solve it. X probability, not probability, expected value is equal X win times probability of win. And since loss is a negative 6, it's going to be minus 6 times probability of plus X lose times probability of lose. So from here we have $210 times probability of win 0.026316, and then plus -6 times 0.973684. Now I wrote down this way so you can see it, because 6 is negative, but mathematically we don't need it. All I can do is just take off this plus and just put here minus 6 times this. And if you solve it, you are going to get negative 0.31574. Negative 0.31574. Okay, so this is going to be our expected value. So people are going to lose at $0.31574. Okay, this is the first answer. The expected value is negative 3.1572. If we round it up, oops, it's going to be negative 0.32. All right. Now, in the second question is, how much would you expect to lose? Okay, so the player would expect to lose how much? We have total how many 1,000 times, right? If we are playing 1,000 times, here it is, and on each game we are losing at a 0.32 amount of dollars, then expect to lose, total expect to lose, it's going to be negative 0.32 times 1,000. So, or instead of approximately 0.32, I can write down negative 0.31574 times 1,000. And it's going to be 1, 2, 3. Position point is here. So for 3 positions, because I have 1, 2, 3 zeros, I'm going 1, 2, 3 zeros. I'm going to get negative. I'm going to get $315, 74 cents of loss. Yes? Okay. So over $1,000. Now the question doesn't ask to put negative sign. It just asks you, because it says to lose, so you don't put negative anymore because it already lose, meaning you are losing. So I take this negative sign, $315, 74 cents, dollar sign. Okay, question number 10. This is gonna be pretty easy. Moving to binomial distribution. I am going to upload the calculator for binomial probability. Okay, so let's see what we have. Find the mean variance, that's question number 10. Find the mean variance and standard deviation for the binomial distribution with a given value of n and p. All right? So let me open the formula. Probability, we have n and p. Okay. So the formula for the mu for binomial distribution is, let me write down, n is equal, how much here? 60. P is equal 0.4. If we have P is equal 0.4, then Q we can find out is a 1 minus 0.4, which is equal 0.6, yes? Okay. So the mu, which is average for the binomial, the mu for binomial distribution is equal n times p, which means we take 60 times 0.4 and we are getting 24. Okay, next we are going to find out variance for the binomial distribution. The variance for binomial distribution is equal n, p, and q. So that is going to be equal 60 times 0.4 times 0.6. And that is going to be equal 14.4. Okay, and the standard deviation is going to be square root of NPQ, which is going to be 3.8. All right, this was pretty straightforward, so we are taking break after previous problem. It's too much typing and reading. Okay, back to again solving problem, question number 11. So a state lottery randomly chose 7 balls numbered from 1 through 37 without replacement. Let me copy and paste again this problem so you can read it also. Okay, question number 11. The state lottery randomly chose the 7 balls numbered, so let's highlight them. 7 balls. Oh, there are 2 of them, 7 balls. Okay, numbered from 1 through 37. Okay, 1 through 37 without replacement. All right, you choose 7 numbers and purchase a lottery ticket. The random variable represents the number of matches on your ticket to the numbers drawn on the lottery. Determine whether this experiment is binomial. If so, identify the values of N, P, and Q. The values of N, P, and Q. And list the possible values of the random variable. Okay, let's get going. So total, what do we need? We need to know that if we have, first thing, the fixed amount of trial, yes? Okay, to determine if the experiment is binomial experiment or not. So fixed amount of trial. Next, we need to find out that if there are only two possible outcomes. Okay. Number three, we need to find out if what's the probability of success and if it's the same for each trial. And number four, we need to find the random variable x that counts the number of successful trials. Let me go over it one more time. So to have a binomial experiment, number one, the experiment has to have repeated for fixed amount of trials. Okay, and all trials have to be independent. Number two, there has to be two possible outcomes total. That's all. It doesn't matter what kind of outcomes. Two outcomes. Number three, we have to have probability of success, and the chance of probability of success for each trial is the same, and it should be the same if the trials are independent. And number four, the random variable x will count successful trials. Okay, so since the balls are being chosen without replacement, look here. What does that mean? You chose the total 7 balls. First time you chose 7 balls. You didn't replace it, put it on a side, which means for the second time you have already 6 balls. That is already not independent, right? It's going down already, amount of balls, right? Third time it's going to be 5 balls, and so on. Which means it is already not a binomial experiment. So, experiment is not binomial. What is happening? Experiment. Since they updated this one note, it's not working properly. See, I'm trying to delete, clean, and it's putting all scratches around. The experiment is not binomial. Period. So which means that you cannot identify n, you cannot identify probability of success or q. So everywhere it goes, it's not binomial. Next question. Question number 12. Okay, question number 12. A survey asks 1,400 workers, has the economy forced you to reduce the amount of vacation you plan to take this year? 47% of those surveyed say they are reducing the amount of vacation. 30 workers participating in the survey are randomly selected. Okay? The random variable represents the number of workers who are you do think hold on, who are reducing let me write down who are reducing the amount of vacation. Decide whether the experiment is binomial experiment. If it is, identify NBQX. Okay, so first let's identify if the experiment is binomial. So first of all, how many workers there are? Okay, so first we need to determine whether the experiment is a binomial experiment or not. So we need to check if the experiment is repeated for a fixed number of trial. So how many total trials are there? In our case, we have 30 workers participating in the survey, right? Here it is, 30 workers, which means it's going to be our n. Let's say, assuming it can be binomial, n is going to be equal 30. Total amount. They were participating in the survey. All right. So, how many outcomes are there? There are only two possible outcomes, right? So either the worker is reducing amount of vacation or is not reducing, correct? So the second outcome, condition also is working. So we have only two outcomes: either reducing the vacation or it's not reducing vacation. Okay, and how about probability of success? Probability of success we are given because it says 47% of those say they are reducing. So that's a probability of success, 47% or 0.47. Accordingly, we can figure out Q, 1 minus 0.47. It's going to be 0.53, right? And now the last thing we need to know if we have the same, and probability is going to be the same, right? It doesn't depend. So one worker not planning vacation doesn't mean the other one is not planning vacation also, correct? Okay, so which means so it's independent and successful probability of success repeating from one worker to another worker. And the last one, the amount of success. Since we have total 30, we have total 30, then amount of success, it's gonna go from how much? Maximum, it's gonna be 30, right? So X is gonna go from 0, 1, 2, 3, any amount of successful trials gonna be, let's say 28, 29, maximum gonna be 30. Yes? Okay, let's then answer given question. Is the experiment binomial? Yes, it is binomial. That is question A. It is binomial. Yes. For analysis above we can say it is binomial experiment. Okay. Experiment. Next, what is the success in the what is a success in this experiment? That selecting a worker who is reducing the amount of vacation, because this is our concern. Remember, I told you it doesn't have to be success and failure. Subject of our interest is the success in our experiment. So, and it is success here is going to be reducing the amount of vacation. This is subject of our interest. So, the success in this experiment is workers who are reducing the amount of vacation. Okay. Next, the value of n, we already have it. I can write down total amount of trials is 30. Okay. What else we have? Probability of success. I already did all this. So probability of success is 0.47. Accordingly, probability of failure 0.53. Anything else we need to answer? Yeah, and x also we have already. X can go from no success whatsoever, 1 success, to 3, and maximum can go till 30, right? Okay. All right, we're done. Moving to question number 13. So what do we have in this question? Question number 13. Here we are going to do binomial probability. So 75% of household households say they would feel secure if they would have $50,000 in saving. Okay. In savings. You randomly select 8 households. Randomly select 8 households. Okay? And ask them if they would feel secure if they had $50,000 in saving. Okay. Find the probability that number that says they would feel secure is exactly 5. X is equal 5. And then more than 5. And then less equal 5. All right? All right. Let's see. The formula we are going to use is going to be probability of x is equal n factorial over n minus x factorial times x factorial. Probability of x q to power n minus x. Okay. So what do we have here? I'm going to place the link to the calculator for binomial probability. Or whoever wants to calculate, you plug in the formula, be my guest. So I'll use one. I will plug the data in the formula. I will solve one. But if you want to use calculator, you can pick it up from the comment. So what do we have here? We need n, p, and q, right? So our n is how much? It says we randomly select 8 households. So this is going to be our n is equal 8. Okay. How about probability of success? It's going to be 75%, right? They said they would be secure if you would have $50,000. So probability of success is 75% or 0.75. Accordingly, hence, Q, probability of failure, is equal 1 minus 0.75, which is going to be equal 0.25. Okay, at the same time, x is going to be given, right? 5. We need x 5, greater than 5 and less than 5, right? I'll do x is equal 5, let's say. Let me plug it. Probability x is equal 5. It's going to be equal n factorial. Where is my n factorial? Here, 8 factorial. And in denominator, n minus x. So n is 8 minus x is 5 factorial times 5 factorial, and then times 0.75 to power x. X is power 5. And then q is 0.25 to power n minus x, meaning to power 8 minus 5. Yes? All right. Let's see what we get. So we have, at the bottom, I'm going to have 8 minus 5, 3 factorials. And then I will have 5 factorials. So 8 I'm going to open only till 5 factorials. 8 times 7 times 6 times 5 factorials. So times 0.75 to power 5 times 0.25 to power 8 minus 5. Okay? So this factorial, this is gone. 5 factorial, 5 factorial. This 3, let me open it. I can open this 3. 3 factorials, it's going to be 3 times 2 times 1. Right? I can reduce 6 and let me pick smaller. 6 and 3, this is 1. This is going to be 2. And then this 2, what else I can pick? This color. These 2 I can cancel with this 2 color, with this 2. And what do I have here? I have 8 times 7, and that's it, times 0.75 to power 5 times 0.25 to power 3. Okay. So if you do all this math, you are going to get 0.208. All right? 0.208. That is probability for x is equal 5. Okay, next we are going to get how much we need. X greater equal 5. Okay, x greater equal 5, which means what I have to do, greater equal them total, I have 8. So I need to find probability greater to 5, probability of x greater than 5 is equal probability of 6 plus probability of 7 plus probability of 8, right? Because total we have 8, maximum is 8. Therefore, greater than 5, 5 is not included, has to be greater than 6, 7, and 8. And if you plug the data in the calculator, or if you wanna, you can solve it, then you are going to get 0.679. And for the probability less equal 5, less equal 5, where 5 is going to be included, obviously, it is going to be 1. The best way, you either can add the probability of 0 plus probability of 1, 2, 3, 4. Or you go backwards by method of complement. All you do, take 1 minus probability of x is greater than 5, and you will get equal and or less. So from here, 1 minus 0.679, it's going to be equal 0.321. Okay? Since this is lasting too long, I'll place continuation in the next video. So to make sure you have time to work on it. Okay, thank you for watching.